just to see how this works a little more. Again, all we're doing in this section is just setting up problems. And so it's not the most exciting section from a mathematical point of view, because we're not solving any problems yet, but we will solve them soon. Okay, I'm going to pick a good one out of here. Okay, let's do this one here. So here's our other example that I will do. So we have a toy company, let's say. The toy company produces 3 kinds of dolls. 3 kinds of dolls, and they give them weird names on here. So I'll stick with those. We got the Scary Harry doll, the Horrible Harriet doll, and last but not least, there is the Glob. I don't know who came up with these names. The Glob. Anyway, so we have a toy company that produces these 3 dolls. And there are 3 steps. So to produce a doll takes 3 steps. Three steps. 1, we have to make the body out of plastic. 2, we have to give them clothes. And 3, we have to add some special features to make each one special, right? So these are the 3 things included in the production of a doll. I have 3 different types of dolls, 3 steps to produce a doll. Where is, oh, here we go. Now I'm gonna give you guys a table. Basically, I'm gonna illustrate all the information. Doing each of these steps is gonna require a certain amount of material, and we just need to keep track of how much material each doll requires. And so that I'm gonna give you that information in a table, so it's nice and convenient. And then we will see how to find the objective function and all that stuff. So here's our table. Scary Harry, Horrible Harriet, and the Glob. And we're going to make this nice table. All right, so here's what this says. To make a doll, of course, is going to take plastic. It's also going to take time for clothes. And then time for special features. So this will be time for clothes and time for special features. Okay. And so plastic will be in ounces. The time will be in minutes. And so it takes, for a Scary Harry, it's going to take 4 ounces of plastic. It's going to take 3 minutes to put on its clothes, and it's going to take 2 minutes for its special features. Horrible Harriet is going to take 3 ounces of plastic, 4 minutes for clothes, 4 minutes for special features. And the Glob is going to take 9 ounces of plastic, 1 minute for clothes, and 3 minutes for special features. Okay. Furthermore, when I sell these dolls, I get a certain amount of profit. So there's also a certain amount of profit for these guys. And it'll go, so this will be for Scary Harry, Horrible Harriet, and the Glob. So for Scary Harry, how much profit do I make? I'm going to make $1. $1. For Horrible Harriet, I'm going to make $1.25. And for the Glob, I'm going to make $1.50. Those are my profits. So I have all of this information. This is all going to be put to use here, just to set this up. Okay, so 3 different types of dolls, 3 different procedures to manufacture them, each with a different amount of material, either plastic or some amount of time to do each of the other two steps. And then I have the profits for each type of doll when I sell one. And of course, our question is going to be, how are we going to maximize profit? So we want to maximize profit. So that's our big question, right? How to maximize profit. Of course, when I say how to maximize profit, I really mean how much of each type of doll should I produce to maximize profit? What should my production schedule be to produce, to maximize the profit? So I need to convert all of this information into an objective function and a collection of constraints. That's what I need to do. And so let's go ahead and do that. So hopefully you guys have written down this information. I have it in front of me so I can still use it. But so we need all this information as we go. And so probably the first thing I always do, we'll write down the objective function, and then we'll write down the constraints. So again, we're trying to maximize profit. So for the objective function, it should again represent profit. It should represent profit. And so I need my variables. What should my variables be? Well, how many variables do I need? I had 3 different types of doll. So I probably want a variable for each doll because to represent the profit, I need to know how many of each doll to produce. So maybe we'll have X is the number of scary Harrys. Y is the number of horrible Harriets. And Z could be the number of globs, right? Okay. So I have 3 variables, 1 for each doll. Okay. Now let's collect these in our profit function, or objective function. And this will be P for profit equals, and then something involving these. We know the profits for each one. For each scary Harry, I make $1. So that's going to just be 1x, or just x. For each horrible Harriet, I make $1.25, so that's plus 1.25 y. And for each glob, I make $1.50. And so I get 150z. So here's my objective function. Okay. Next, I need my constraints. And of course, I'm kicking myself now because I realized I forgot to include one more bit of information in this problem, which is how much plastic we have available and how many man hours we have available as well. And so I have to tell you that, of course, otherwise we can't make constraints. So let's just suppose that there's 160 ounces of plastic available. I have 160 ounces of plastic, and I have 50 hours for each of putting on the clothes and doing the special features. So these are going to give me these will give me my constraints. I have 160 ounces of plastic total, and for the other 2 jobs, I have 50 hours each. So we should just keep that in mind. I forgot to tell you that, so I'm a little annoyed with myself, but that's fine. We will carry on from there. So these will give us our constraints. So let's write down our constraints. So let's look at the plastic first. Basically, with the constraints, I'm going to have one inequality for each step of the process, right? So I'm going to have one inequality that represents plastic. I know there's a certain amount of plastic used up by each doll, and I have this much plastic to use in total. So I need to put all that together in an inequality that represents the amount of plastic that I can use. So we'll do a plastic one first. And I'm just going to ask how much plastic am I using for each doll? And everything is in ounces, so I don't have to convert any units. For a scary Harriet, it was 4 ounces, so that's 4x. For a horrible Harriet, it was 3 ounces, so that's 3y. And for a glob, it was 9 ounces, so that's 9z. The 9. And I have 160 ounces to use, so that's less than or equal to 160, because I can't use more than 160. That's all I have available. So here is my constraint for plastic. 4x plus 3y plus 9z is less than or equal to 160. Now for close, we're talking about time. In the table, I gave it to you as minutes. Here I'm giving it to you as hours. Sorry, these are minutes. Yeah, so we'll stick with minutes. We're not converting here. These are minutes. Man, I'm messing this up. Sorry, guys. 50 minutes for each of the close. If it were hours, we need to be careful and convert, but we'll call these minutes. So everything's in minutes. So our table is in minutes. We have 50 minutes for each one. So let's say the following. For close, how many minutes does it take to put on the close for Scary Harry? According to our table, it was 3 minutes. So 3x. For the Horrible Harriet, it was 4 minutes. So that's 4y. And for the Glob, it was 1 minute. So that's just z. And then I am bounded by 50 minutes. I only have 50 minutes available total. Lastly, there are special features. So going to be one more inequality here. And again, I just ask how many minutes did it take for each one. So for the for the Scary Harry, it was 2x. For the Horrible Harriet, it's 4 minutes. And for the Glob, it's 3 minutes. So 2x plus 4y plus 3z. And again, I only have 50 minutes available. 50 minutes. So here are my explicit constraints. Lastly, I should have my implicit constraints. And what should those be? Well, they should be just like I had before. Again, I'm producing a number of dolls, so it doesn't make any sense to talk about a negative number of dolls. And so my implicit constraints ought to be that each of these variables is not negative. So I should have an x is greater than or equal to 0, y is greater than or equal to 0, and z is greater than or equal to 0 as my constraints. Otherwise, none of this will make any sense if I allow my variables to be negative. Okay. So let's pause and see if there are any questions. We're done setting this one up. So does anyone have any questions? Okay. So again, all we've done is set up the problem. We haven't solved anything yet. We'll see how to solve. It's going to end up involving our inequalities here. We're going to have to learn how to represent solutions for a system of inequalities like this. And so starting in the next section, we're going to learn how to do that. But for now, we're just setting these up because there's a lot of parts. And so I think I'm going to be done doing examples on the board now because I fumbled enough with these up here. And it's best for you guys to sort of get your hands-on practice. I don't know how much time we have left. Man, we have like 15 minutes. And so I posted that activity 7.1. Maybe if you guys want, we could start working on that for the remainder of class today and then spend some more time on it tomorrow. The entire activity is setting up these problems. And so that's really going to be the best way to learn is to start doing these. So we'll spend the rest of class today just getting a start on the 7.1 activity. Unless anyone has any questions. All right, well, let's spend the rest of time today starting that activity. I'll bump you guys into some rooms. Basically switching up the rooms because of attendance, but all right. So here we go.